Okay, so today we're just doing a little bit of review for the top 20, and I had kids pull out 5 problem types that they were generally not really good at. I agree, these are ones that come up a lot where people get them wrong. So don't be feeling sad if you get 2 wrong out of these 5, because this is like some of the hardest of the top 20. How many of you are done with the 1, 2, and 3? Okay, good. So if you're not done with the 4th and 5th, I know some of you aren't, just keep cranking them out. But I'm going to show you the answers, how to do the answers for 1, 2, and 3 here. Number 1, numbers go with numbers, and variables go with variables. So that has something in common. And if you can factor it, you should. So the 28 can factor. I know you don't think of that as factoring sometimes, but it is. 7 times 4 is factoring it. Okay? And this is 7 times 3. And why is that good? Because then you can see that the 7s will cancel each other. So my answer is going to have a 4 on top and a 3 on the bottom. How many of you had that part of it right? Okay, good. Then after that, it's just this. If I have 5 on top and 7 on the bottom, then the 7 wins, so to speak. And there's still going to be, once all the canceling happens, I like to think of this as x to the 5th over x to the 5th times x to the 2nd. Because that way, the x to the 5ths can cancel, and what you're left with is just an x to the 2nd on the bottom. I know some people will say, well, can't you just do 5 minus 7? Yeah, but then you're going to get x to the negative 2. And then if you leave a negative in your answer, that wouldn't be good. So, all right. The other one is y to the 7th. I'm going to think of that as y to the 6th times y over just a y on the bottom. And then I can cancel those y's. Yes, you can do it by just saying 7 minus 1 is y to the 6th. Oops, I just canceled the wrong thing. Sorry. That y cancels that y. And so, yes, you can just take 7 minus 1 is 6, and that one does work easier this time because the top number is bigger. Final answer, 4 over y, or sorry, 4y to the 6th over 3x squared. Raise your hand if you had that one right. Okay, good. She can replicate it, so. Otherwise, I was thinking the same thing. I was like, oh man, did somebody just rip one over there? I know, it was the pen. Yep, see, as long as you can replicate it. All right, good. So number 2, we've distributed this out. 8x, and then multiply this out, minus 28, minus x, and here's the most common, oops. That negative has to also go over here. So it's positive 3 equals 2x plus 6. I know, right there, I guarantee you somebody forgot that because that happens all the time. All right, then I'm going to put my x's together. 8x and that x makes a total of 7x. And then this number and this number can go together, and that makes minus 25. So 7x minus 25, I'm going to bring it up here with some room, is equal to the 2x plus 6. Then there's x's on both sides. You get rid of the smaller one. Sorry, 2x. And I get 5x minus 25 equals 6. Then I add 25 to both sides. 5x equals 31. X equals 31 fifths. Raise your hand if you had that one right. Almost everybody, nice work. Okay, now I'm going to erase here so I get some room to do number 3. On number 3, I needed to square root both sides. And it was absolute value of x minus 9, and that's the key, is the square root of 11. The key is knowing that the square root of a variable needs an absolute value. Because then, hopefully, you remember these get broken into 2 equations. Exactly what you see without the absolute value, and the exact same thing again. But that would be crazy, because that's the exact same thing. So I make one little tweak, and I say, oh, but I'll make this one negative square root of 11. Now I can add 9 to both sides, and x equals root 11 plus 9. And over here I add 9 to both sides, and it's negative root 11 plus 9. That's the toughest one, I would say, on the whole page, who had that one right. And we're down to only half the group had that one right. It's root 11 plus 9, and negative root 11 plus 9. If you said, okay, just to clarify, if you said this answer, plus and minus the square root of 11 plus 9, that would have been the same exact thing, if you think about it. It's just mine's broken in two parts. Root 11 plus 9 and negative root 11 plus 9. So if you said this, it's the same thing. So in other words, you're just asking, can you move the 9 to the front? Yeah, you could move the 9 to the front also. All right, moving on to problem 4. Problem 4, the green one there. I have to factor it. If you can factor it, you should. So you can factor it, 2x and x. And what goes here and here? I don't know, something that multiplies to 6. And I can pick anything that multiplies to 6, but I'm going to try 2 and 3, but it might be 6 and 1. So I'm going to try 2 and 3, and I'm just going to try something. But do you know why this logically can't be right in here? Because I could have factored the 2 out if there was a 2 there. So there can't be a 2 there. Now another way to do that is say outside, inside, does that make negative x? And it does not. Okay, so anyway, but I know the 2 can't be there because otherwise that creates something where I would have had to factor a 2 out. And you can't factor a 2 out of everything. So there can't be a 2 there. Maybe there could be a 2 there though. Let me check this. And I need one of them to be negative. So I'm going to make this one negative and just try it. I don't know if that's right or not. I'll check. Outside, 4x. Inside, negative 3x. That makes positive x. Ah, exactly the opposite of what I wanted. But that's cool. Because if it's the exact opposite of what I wanted, I change this sign to plus and this sign to minus, and I know I've got it. There. How many of you factored it right? Good. Then 2x plus 3 equals 0, and x minus 2 equals 0. And then I subtract 3. 2x equals negative 3. X equals negative 3 halves. And over here, add 2, x equals 2. 2 and negative 3 halves. And then last but not least, to this one, we needed to multiply by 3 and 5 everywhere. That'll get rid of our denominators. Not just 3, but 3 and 5. Some people are like, why don't you just multiply by 15? The reason I like to keep them separate like this is because now they'll just cancel right directly. I don't need to factor the 15 into 3 and 5 because they're already factored. So I like to use the 3 and 5 separate instead of 15. Then I have 5a minus 3 times 2 is 6 equals 5 times 3 times 1 is 15. And then you add 6 to both sides. 5a equals 21. A equals 21 fifths. I had that one right. Okay, good. Did anybody get the coveted 5 out of 5? All right. And I bet it was that square root one, as it seemed like it got most people. So, yes, ma'am.
So for square root, when you square root, is it always going to be plus or minus?
I don't like you to think of it that way. Because see, here's the problem. If you think of this as when you do the square root of this, and people think, oh, so I just have to put a plus and minus on this, and I'm going to go x plus 3 equals plus and minus square root of 11. That's not right. That's not what's really happening. Because you're sort of saying that you think the square root of 11 is positive and it's negative, and it's not. What's really happening when you do this problem is you're square rooting a variable which creates an absolute value. That's the thing you got to get for pre-calc level. And then that's what creates two equations. So you also need to know how to do absolute values. That's on the ACT also. They might just start with this problem that's in green here. You got to know how to do that. So it makes two equations. One is exactly the way you see it, x plus 3 equals square root of 11, and the other is exactly the same thing. With one little change, you go, okay, what's different? I got to put a negative in front of that one. You need to get that process. Please don't just slap down a plus minus and then subtract 3 from both sides. It's going to get, even more intense, like when you get higher up into pre-calc, and you got to know what to do. You can't just say, oh, I'm going to take the square root of both sides, and then, wait a minute, that doesn't even work at all. You got to know what to do with absolute values. They split into two equations, etc. But in this one, it's a trick question because absolute values always come out positive. So how is an absolute value ever going to come out to equal a negative 12? It won't. It's a good thought. Imaginary numbers maybe, but no, not even with imaginary numbers. So there is no way to do this problem. And therefore you'd say, what's the solution? No solution. All right, it's kind of like this one. 2x plus 7 is equal to 2x plus 8. You solve that for a while and you'll end up figuring out that apparently 7 equals 8. Is it true? Does 7 equal 8 when you subtract 2x from both sides? No. And if you come out with a false statement, then it's saying that, when is that true? Never. So there is the answer of no solution sometimes. Okay. Good chance to talk about top 20 stuff. They aren't going away. I told you since 3 months ago that they weren't going to go away, and they aren't. They're still here. And if you haven't mastered them yet, take this opportunity to do it, because it'll help you so much, not only for the rest of this class, but on your ACTs also. Okay, and today we need to also just do a little bit of review of what we did yesterday. Today's a nice, easy day for, don't have to learn too much stuff. So yesterday's stuff were problems that came out like this. 3 plus and minus the square root of negative 12 all over, let me make this 30. All over 6. Would you see if you remember how to handle something like that? I'll give you a hint. You start with the square root of negative 12 and you boil it down some. Then you do some factoring and some canceling, and you should get an answer that's called a complex number. It's got I in it if you do it right. I'll pause for a second while I give that a try. How about we do root 4 and root 3 to start with? Is that okay? All right, and then where's the negative though? Yes. And then what's the name for this? What's this? So it's 2i root 3. Raise your hand if you simplified that right. Okay, good. Then you got to factor the top. What comes out of both 30 and 2? 2 does. What do I have left? 15 plus and minus the square root of, wait a minute. I got to take a 2 out of this now, because this is all gone, and simplify it down to this. Okay, so the 2 comes out, and I have I root 3 left. And on the bottom, I like to think of that 6 as factored into 2 times 3. That way, they're just sitting out there waiting to be canceled. Doink, doink. And there's my answer. Raise your hand if you had that one right. Okay, good. Now, did some of you take the extra step and go 15 divided by 3 separately? 15 divided by 3 separately is 5. Plus and minus I root 3, but that part hasn't been divided by 3 yet, so we'd say divided by 3. That's also an okay answer, and I like it a little better just because the real part is separated from the imaginary part. And no, you don't have to do that last step. Yes?
So, if it's impossible to get roots, what is the likelihood of that?
If it's impossible to get roots, okay, you can't see these imaginary roots on a graph. Like, I think I know what you're saying. Like on a parabola, normally your roots are like, they represent these 2 spots, okay? But what these are the answers to the question, which are supposed to be the x-intercepts, but remember, this parabola doesn't touch the x-axis. It's like a parabola that's up here or something. So what are they? They're nothing you can see on the graph. But they are things that if you put them back in the original equation, I didn't even give you an equation on this one, but there would have been an equation, right? If I take these answers and stick them in for x in the original equation, it will make the answer turn out to be 0. So let me show you one that's like that. Let's say I had x squared plus 3x plus 7. Okay, I happen to know that that one's not going to have real roots. Okay, but once I get on and you get all done with this thing, and you get an answer, and it comes out to like the same weird thing, 1 plus and minus this I times the square root of 3 all over 2. What is that? It's the thing you could stick into this equation so that it forces it to equal 0. They're the things you could put in for x that force it to equal 0. You can force this equation to come out to 0. The only thing is you have to use I in your answer, which doesn't exist for real, but it's a way to kind of trick the equation into working. Yes?
You can't factor the denominator with the same factors still factor the bottom.
Good question. Let's say that the denominator had a 17 in it. And what you're saying is there even any point, if this had let's say a 21 and a 3, you could factor the top, you could get a 3 to come out of both of them, but like you're saying, there'd be no point because the bottom can't factor, then you're right. We almost always set them up so that they will come out nice, so that something will cancel. Like let's say I did this, then a 3 comes out of both of them, and then the bottom must have a 3 in it. Well, if you happen to get a problem where the bottom can't factor, then there's no point in factoring the top. But I will tell you, both on the ACT and problems you're going to get from us, 9 times out of 10, the point of the problem is to see if you can cancel stuff. And so it almost always will factor. Okay, those are all really good questions, and I hope you've got the basics down for doing complex numbers. And I think the only other thing that I want to brush up with you on one last topic is I squared. Do you remember just memorize? What was that? I squared is what? -1. So I want you to figure out, don't say it, write it on your paper, what would I to the 7th be? If I remind you that you could make that into a whole bunch of I squareds and then maybe one I, hopefully you can like reason out, oh, so it's really this, which means you can get an answer. There is an answer, it just might have an I in it. Sometimes the answer is just 1, sometimes the answer is -1, sometimes the answer is I, sometimes the answer is -I, but they all simplify down to something. Remember me saying if you can factor it, you should? This is actually just factoring the I to the 7th. Strategically breaking it into a multiply problem that helps you. I do. Yep. Okay. So we have, I would say, I to the 7th you should break up into a bunch of things you know. And what's the main thing you know? You know I squareds, right? So let's make it a bunch of I squareds. How about 3 of them? Is that enough? Well, it's close. So what do I need also? Another I. That breaks it up, and see how that's really factoring it? I'm turning it into a multiply problem. And now that's -1, that's -1, that's -1. And when I do, what do I get with -1 times -1 times -1? -1. So then the final answer is -1 times I, which is -I. How many of you got that right? Ooh, lots of you. Question? Now you're thinking about multiplying them. If you have a to the 3rd times a to the 3rd, it is not a to the 9th. When they're like this, you add them. You get how this plus this plus this plus this adds up to 7. If you want to have them be multiplied, then you'd have to have this kind of thing, which is not what we did. But if you did this, that would be a to the 9th. Okay? All right. So, what's I to the 18th power? You shouldn't have to actually write down a whole bunch of I squared. You should be able to just think about it. Would you agree that this is a whole bunch of I squareds being multiplied? How many I squareds would you have to multiply? 9 of I squareds. Each I squared is equal to -1. So -1 times itself how many times? So it's effectively like -1 to the 9th power. And what's that? The answer is -1. How about this? Let's see if this makes your mind explode. Would you agree that that's I squared to the 9th because of the thing we were just talking about? 9 times 2 makes 18. So then that's really -1, right? -1 to the 9th. And that means -1 times -1 times -1 times -1. And all you need to know then is if there's odd number and negative signs, the answer is negative. Because you know it's got to be 1. Because it's 1 times 1 times 1 times 1 times 1 times 1. Yeah, anyway. Yes? Very good. So summarize that again. If you said I to the 18th or like I to the 12th or like I to the any even number, right? Then, well, let's try 2, I to the 2nd. What's I to the 2nd? -1. What's I to the 12th? -1. What's I to the 18th? -1. Okay. And then how about stretch it a little further? What's I to the 19th then? -1 times I, which is -I. Good. Then we go back to the I to the 20th, and that would be -1. Okay, good. That's a good exploration for today. Now, I have one last closing activity for you. And tonight, your homework is to do version 2 of the top 20. All right. And that's all I have for the video for today. I'm going to do the little activity not on the video.